For generations, we've imagined visitors from other worlds, crafting stories and legends about beings beyond our own. Sometimes friendly, offering advanced knowledge and peaceful exchange, sometimes terrifying, representing existential threats to humanity. But beyond the realm of fiction, the real question persists. Are we truly alone in the universe, or are there other voices waiting to be heard? Today, science, not just imagination, drives our search for answers, providing us with the tools and methodologies to explore the cosmos in a systematic way. Our sun is one of hundreds of billions of stars in the Milky Way, each potentially harboring its own retinue of planets. And our galaxy is just one among billions more, scattered across the observable universe, each a vast island of stars and possibilities. With so many stars and planets, could Earth really be unique? A singular oasis of life in an otherwise barren cosmos? Science urges us to follow the evidence, not fantasy, to base our conclusions on observation and experimentation, rather than wishful thinking. We know how life began here on Earth, and we use that knowledge to guide our search elsewhere, looking for similar conditions and building blocks. We're cosmic detectives, looking for clues across planets, analyzing their atmospheres and surfaces for signs of habitability. Moons and the vastness between stars, searching for the faint whispers of life in the cosmic background noise. This isn't about chasing UFOs, it's a methodical, patient quest, driven by rigorous scientific principles and cutting-edge technology. We'll explore Mars, icy moons, and distant exoplanets, searching for places where life might hide, thriving in unexpected environments. We'll listen for signals from the stars and study the chemistry of alien worlds, analyzing their atmospheres for biosignatures that could betray the presence of life. The search for life is really a search for our place in the cosmos, a quest to understand our origins and our destiny in the grand scheme of things. The universe is vast and mysterious, filled with wonders beyond our current comprehension. Are we ready to listen for its answer, to embrace the possibility that we are not alone? Life, as we understand it, has a fundamental requirement: liquid water. It's the solvent of life, facilitating countless biochemical reactions. Therefore, scientists diligently follow the water, embarking on a quest to identify worlds where this precious substance might exist in its liquid form. This search often takes us beyond our own solar system. But for life as we know it, water must be liquid, not frozen solid as ice or vaporized into steam, which critically depends on a planet's distance from its host star and the amount of energy it receives. This Goldilocks zone, also known as the habitable zone, represents the orbital region around a star where conditions are neither too hot nor too cold, but just right for liquid water to exist on a planet's surface. Earth sits comfortably within our sun's habitable zone, enjoying a stable climate that allows for vast oceans and thriving ecosystems. In contrast, Venus is too hot, with a runaway greenhouse effect making its surface inhospitable. And Mars, further out, is mostly frozen, though evidence suggests liquid water may have flowed on its surface in the distant past. Powerful telescopes like the James Webb Space Telescope with their advanced capabilities now let us study the atmospheres of exoplanets residing in these Goldilocks zones, meticulously searching for the telltale signs of water vapor and other biosignatures that could indicate the presence of life. But it's important to remember that life might not necessarily need sunlight at all to exist and flourish. Consider moons like Europa orbiting Jupiter and Enceladus, a moon of Saturn, both located far from the sun's warmth. These intriguing worlds may conceal vast oceans of liquid water beneath their thick icy crusts, warmed not by sunlight, but by the constant push and pull of tidal forces generated by their parent planets. These hidden seas, shrouded in perpetual darkness, could potentially host unique forms of life adapted to these extreme conditions, much like the diverse ecosystems that thrive around deep-sea hydrothermal vents on Earth, far from the reach of sunlight. Therefore, the Goldilocks zone, while a valuable tool, is just a starting point in our search for life beyond Earth. Ultimately, life may surprise us, existing in forms and places we haven't even imagined yet. The vastness of the cosmos presents a profound question. How do we even begin to search for life beyond Earth? What strategies can we employ to detect signs of life across such immense distances? We listen intently to the whispers of the universe, and we actively explore the planets and moons within our reach. SETI, the search for extraterrestrial intelligence, diligently scans the skies, meticulously searching for radio signals or other technological signatures that might originate from intelligent civilizations residing on distant worlds. So far, the universe has remained stubbornly silent in response to our inquiries, but it's crucial to remember that we've only just embarked on this incredible journey to listen for other voices in the cosmic choir. It's a bit like trying to isolate a single faint voice amidst the overwhelming cacophony of a packed stadium, filled with countless sources of noise and interference. In the meantime, we're actively dispatching robotic explorers to nearby worlds within our solar system. Mars rovers are diligently digging beneath the surface, searching for any telltale signs of ancient microbial life, carefully analyzing rocks and soil samples for the presence of biosignatures, which could indicate past or present biological activity. Billions of years in the past, Mars was a very different place, boasting rivers, lakes, and potentially even oceans, raising the tantalizing possibility that life could have originated and thrived there during that more hospitable period. Future missions are being planned to potentially drill through the thick ice shell of Europa, with the ambitious goal of exploring its hidden ocean and searching for life in those alien subsurface waters. NASA and other space agencies are actively designing and developing advanced probes and technologies to make these ambitious journeys a reality. Each new mission we undertake extends our reach further into the cosmos, allowing us to directly touch, sample, and analyze the surfaces and environments of other worlds. Whether we choose to listen for distant signals or actively explore nearby planets, our efforts are always driven by an insatiable curiosity and the unwavering hope of making a groundbreaking discovery. The search for life beyond Earth is truly just beginning, and the possibilities are endless. What incredible secrets and astonishing discoveries await us as we continue to explore the universe? If we find life, it will likely be simple microbes, not monsters. For most of Earth's history, single-celled organisms ruled the planet. Alien life may be hidden in Martian soil or Europa's ocean, invisible to the naked eye. If complex life exists, it would be shaped by its world gravity, light, and chemistry. Evolution might produce familiar forms, like fins or wings, even on distant planets. But life could also be truly alien, using strange chemistries or thriving in environments we find deadly. Convergent evolution shows that similar challenges can lead to similar solutions, even on different worlds. The universe may surprise us with both the familiar and the bizarre. We must be ready for anything. The real wonder is in discovering what life can be. The cosmos is full of possibilities. Why do we search for life beyond Earth? Because curiosity is in our DNA. The quest to find life is the ultimate adventure, pushing us to explore, invent, and dream. Discovering even simple life would change everything, proving we're not alone. It would reshape our understanding of ourselves and our place in the universe. Finding intelligent life would be even more profound, raising new questions and challenges. But even if we find nothing, the search itself drives science and technology forward. We learn more about our own world as we look for others. The search for life is a mirror, reflecting our hopes and our need to understand. It's a story about the universe, but also about us. And the next chapter is waiting to be written.